Alright, let's move on to talking about fractions now. Now again, we want to build the idea of fractions up from stuff that we've already talked about. And if we think about it, well, fractions are kind of the same as integers in a particular way. And that way is they are a solution to an equation involving a number set that we already know things about. So if we have something along the lines of two integers, a and b, and we make b not b0, we can't have fractions with the denominator of 0, of course. So we're going to define the fraction a over b to be the solution to this equation. B times x equals a. For example, 2/3 is the solution to 3x equals 2. Now, notice that this equation doesn't have a solution in the integers. The integers isn't a big enough set of numbers to have a solution to this. So we're expanding that set. We're defining a new set built up out of the integers in order to solve equations like this. I do want to note one thing. If you remember, the golden rule of equations says, well, we can do whatever we want to both sides of an equation, pretty much, as long as we do it to the entirety of both sides. So I could, if I wanted to, multiply this equation by 2. And if I do that, I get 6x equals 4. Now, these equations have the same solution, of course, because I just manipulated it using the property of equality of multiplying everything by 2. But reading off what fraction comes from this, the solution, well, our a in this case is 4, because our a is what it equals, and our b is 6. So the solution to this is 4/6. And of course, 4/6 and 2/3 are equivalent fractions, which makes sense, right? Since 3x equals 2 and 6x equals 4 are equations that have the same solution, they must, since all we did was multiply both sides of the first equation by 2, these guys must be the same number. We'll talk a little bit more about equivalent fractions later on. But that's a definition of what a fraction is mathematically. But a good way to think about fractions is what is with some sort of unit model. And the idea is as follows. So let's say we have a ones block. So this here is 1 unit. There's my 1 unit. So if I want to, I can break this up into however many pieces I like. So let's say I break it up into 5 pieces, and I want the pieces to be equal size. That's important. So I can say I have 5 of the exact same thing that make up 1 unit. So in this case, I break up my unit into 5 equal pieces. We'll call them fifths. And let's say I want the quantity of having 2 of those pieces. So I have 2 of these fifths pieces, so you could say I have 2 fifths. And the way to visualize that using fractions is to write it like this: 2 fifths. So the number up top is, of course, called your numerator, and the numerator tells you how many pieces you have. Think the word number is kind of in there, so how many you have. And then the bottom number is called your denominator, and that tells you how many equal pieces make up 1 unit. In some sense, that gives you information of the size of each piece. You can see the word or the same root of denomination in there. Denomination in money are things like, $1, $2 quarters, $5 bills, whatever. That's the size of the thing. So that's what denominator means. So this 2/5 means that I have 2 equal pieces, and the size of my equal pieces are such that 5 of them make up 1 unit. Alright, let's look at this little example here. Again, this isn't particularly hard, but I really want to stress what a fraction represents. So, let's say that if a bag of marbles contains 8 marbles, what fraction of the bag do you have if you have, well, we have 4 situations: 2 marbles, 4 marbles, 3 marbles, and 8 marbles. Well, if we're talking about fractions, we have to think about what is 1 unit. So here in the question, it says, what fraction of the bag do you have? So the bag is our unit. This is our 1 unit. So, how many marbles in a bag? Well, there are, of course, 8 marbles. So 8 marbles makes up 1 unit. Okay? So, let's draw this out. It's a good idea to visualize this. Here are our marbles. Alright. So that is 1 bag of marbles. That's our unit. So, we want to have 2 of these marbles. Let's do A first. We want to have 2 of these marbles. Let's say these 2. What fraction of the bag do we have? Well, the question is, well, in order to take 2 marbles, how can we break up this bag into equal size pieces? And in some sense, there's a couple of ways of doing it. Well, one way is, of course, well, maybe we could break the bag of 8 marbles up into 8 equal pieces. So each piece, each marble, is 1/8. So we know our denominator is 8 in this case, since we broke up our bag into 8 equal pieces, each piece having 1 marble. And how many pieces do we have? We have 2 of them. But that's not the only way of doing it. Well, if we wanted to, again, we have these 2 marbles, let's say, we could break up our bag so that the equal pieces are 2 marbles each. In this case, it takes 4 equal pieces to make an entire bag. So if each piece contains 2 marbles, and there are 8 marbles in a bag, then 4 pieces of 2 marbles makes up 1 bag of 8 marbles. And we have 1 of these 2 marble pieces, so it could be 1/4. And you could think, well, I guess that's it. They're the only ways of writing this. But that's not true either. In fact, what else we could do, if we wanted to, I'm going to draw these a little bit bigger. Well, again, we have these 2 marbles, let's say. If we wanted to, well, we could break up the bag into half marble pieces. Nothing's stopping us from doing that. In no place in the question does it say we have to keep the marbles whole. We could get out our saw or whatever and cut the marbles in half. So now, how many pieces make up the bag? Well, now there are 16 halves of the marbles that make up the bag of 8 marbles. So the denominator is 16, and we have 4 of these half marble pieces. And again, if you wanted to, well, nothing's stopping us from breaking up each marble into quarters. And then we have 32 pieces that make up a bag of 8, and we have 8 of those quarter marble pieces. Or we could break it up into sixteenths, or whatever. There are infinitely many ways of writing this fraction: 1/4, 2/8, 4/16, 8/32. If we break it up in halves again, we would have 16 64ths, and we could keep going ad infinitum. So, for the rest of these, just know that there are infinitely many ways of writing this, but I'll just write down 1 or 2 of them. So let's do B. So B is 4 marbles. So let's say we have these 4. And of course, well, one way of doing it is we can make each piece, each equal piece, have 4 marbles. So now it takes 2 pieces of 4 marbles to make up a bag of 8 marbles, and we have 1 piece. Again, we could do maybe 2/4 or 4/8 or whatever as well. 3 marbles. Okay, let's say we have these 3. Now here, we can't break it up into equal pieces of 4 marbles. Let me just draw this and then I'll erase it. So if we break it up like this, well, we don't have complete pieces. So we have 1 complete piece, but then we have half of another one. We can kind of represent that as a fraction later. We'll talk about that in a bit. But for our purposes right now, let's say that's no good to us because we can't write an integer as our numerator. So we can't do this. So this is no good. But we can break it up into 8 pieces. So here we have 8 pieces that make up 1 bag, and we have 3 entire pieces of those 8, so we have 3/8 of the bag. And D, of course, well, we could look at it like this. Again, there are many ways of doing this, but we have all of the marbles. Well, I can, air quotes, break this up into 1 piece of 8 marbles to make up a bag. Why not? So, if it takes 1 piece to make up a bag of marbles, and we have 1 piece, then we have 1/1, I guess, or just 1. And I do want to say, remember, this idea is just a model, right? And it's kind of hard to express if we want to express numbers with negative numerators or negative denominators, or both negative numerators and negative denominators. It's kind of hard to express it via this diagram, but from our original definition, that still makes sense. So we can talk about a fraction along the lines of -3 over -5. Even though that doesn't really have a good physical interpretation using this model, it still fits our definition of what a fraction is. So that's totally fine. And you could see that, well, that means it satisfies the equation -5x equals -3. And if I wanted to, I could multiply both sides by -1, which is the equation 5x equals 3. So we could see that the fraction -3 over -5 is equivalent to 3/5. So just know that even though when we talk about models, it's usually with positive integers, or I should say non-negative integers, negative stuff still makes sense with the definition. All right. And of course, we know fractions and division are very closely related. So let's say we want to divide 3 things into 4 equal groups. If we didn't have the idea of fractions, we would just say, well, we can't do it, and we just have 3 left over. But if we're allowed to break up our units however we want, then we can start to talk about this in a better way. So if we want to do 3 divided by 4, well, let's take our 3 units, here they are, and I want to divide them into 4 equal groups. So the first thing I'll do is I'll take my units and I'll divide them into 4 equal parts. And, well, what I'll do is I will just take one part from each of my units. So I have the blue group, that's 1 group. The red group, that's 2 groups. The green group, that's 3 groups. And the yellow group, that's 4 groups. So I have 4 groups here. 1, 2, 3, 4. So a blue group, a red group, a green group, and a yellow group. They're my 4 groups of equal size. And what size are these groups? Well, they have 1, 2, 3 fourths, or 3 quarters in them. So I have groups of size 3 quarters. And in general, for A divided by B is going to be A over B, and I should say 4B not equal to 0, of course, since we can't divide by 0. And just a quick reminder, because we'll use this notation quite a bit. Remember that Blackboard bold Q is the set of all fractions A over B, where A and B are integers, and B, of course, is on 0. And I don't want to get into kind of the details of how to write this down, so I'll just write down and equivalent fractions are equal. Because we don't want to picture the set having 1/2 and 2 quarters being different. They're just synonyms of expressing the same quantity. So we want to say equivalent fractions are equal in this set. It's just a different way of writing down the same quantity.